Hey everyone, thank you so much for joining in. So, as we progress in today's session, we'll be learning the statistical hypothesis testing. So, we'll look into what exactly is this hypothesis testing. We'll understand about the concept of null hypothesis and the alternate hypothesis. And we will look into the one of the well-known method that's called as a critical value method in performing the hypothesis testing. Then we will look into the concept of p-value method. How do we perform the hypothesis testing by referring to the p-value? Then we will understand about the types of errors that we generally come across in statistical testing. And then we'll take up a case study and a demonstration of the same so that you'll get a complete picture of this hypothesis testing. Now, before we get started, so how many of you are aware of data science and what exactly that is going to do? So here, when we say data science, if I want to specifically talk about this data science here, data science is all about finding the patterns in the data by analyzing the data set in an efficient manner. Now, while finding the pattern, we are going to apply various concepts of statistics and to validate whether my assumption is being exhibited by my model. That is when we perform the statistical hypothesis testing. So the importance of this hypothesis testing is it will help us to validate whether it is a manual one or whether it is an automatic one. So that's the core idea over here. Okay. Now, as part of your learning journey in this data science with Python certification training program, in the module 1, you'll have an introduction to Python programming language and the data science. And the module 2 is about working with sequences and the files. Module 3 is about deep dive into the functions, object-oriented programming structures, modules, errors, and exceptions. Module 4 is about NumPy, Pandas, Matplotlib. Module 5 would include the data manipulation with Pandas library. Module 6 is working with machine learning algorithms and learning the core basics of the machine learning algorithm. And module 7 is about learning the supervised machine learning. And module 8 is dimensionality reduction. And module 9 is about the unsupervised learning. Module 10 is the reinforcement learning. As you can clearly see, each and everything that is required for you to work as a data scientist and to become an industry ready are being covered in this data science with Python certification training program. And it follows a special learning approach that's called as a structured learning approach, which ensures that you as a learner will learn in a progressive manner. It doesn't matter from which background you're from. Because of the curriculum design, you will be able to follow along and become an expert in understanding which technique to apply while analyzing the data set. Okay, now coming back to our session's agenda, what exactly is this hypothesis testing? Now, when I talk about hypothesis testing is a statistical analysis. Here, we are going to put our assumptions about a population parameter to a given test. Now, we use it to estimate the relationship between two variables. Okay, let's take up an example. So we assume that, okay, for a Maggi noodles, okay, so we assume that for a Maggi noodles, there is a lead content of less than or equal to 2.5 ppm. Now, this is my assumption. Okay, now what I'm going to do is, so if you think about the production of Maggi noodles by a Nestle company, they will be producing lakhs and lakhs of products. Now, think about testing lakhs and lakhs of products every day, that is going through each and every product and testing it. So obviously, you cannot test each and every Maggi product which is being produced by the Nestle company, because one, you will be using entire stock in your testing. It will be loss for the business. And even it's not a recommended one. Think about 10 lakhs of Maggi packets that you have to test it. How much time it will take? So obviously, we cannot test each and every Maggi product. So what I'm going to do is I'm going to pick up a sample. Maybe out of 10 lakh products which has been prepared by the Nestle company, I'm going to pick up 10,000 products. So 10 lakh product is the population. And from that population, I'm going to select a sample in this example that is 10,000. So once I select the sample of 10,000, Then, okay, then I'll go ahead and perform the analysis on this 10,000 packets. So what it means is, once I, like, instead of testing on the 10 lakh products, I'm testing on 10,000 products, and whatever the outcome that I'll get, I'm going to generalize it for my entire population. Let's say out of 10,000 packets that I've sold, so I found that all the packets is having the lead content of less than 2.5, then I will report that, okay, the Maggie is safe and the lead content is less than 2.5. Okay, that is the overall way in which that we are going to interpret this scenario. Okay, so that is how we are going to interpret the same. Here, when we talk about the hypothesis testing, so hypothesis testing is an act in statistics where an analyst tests an assumption regarding a population parameter. In the previous example, here the population parameter is actually my lead content in the Maggi noodles, which is produced by a Nestle company. So that we are going to test that assumption, okay, for the population parameter. And this methodology employed by the analyst depends on the nature of the data and the reason for that analysis. Okay, so that's the overall idea. So if I want to give you some more examples of statistical hypothesis, so hypothesis is nothing but the assumption. Maybe we've got a teacher or we've got a lecturer. A lecturer assumes that 60% of their college students come from, let's say, like higher middle class family. So these are all just the statements, or people who smokes, they are more productive, or women use more social media than men. So these are all some of the assumptions that we have. So once we have this assumption, we call this as hypothesis, and we are going to test this hypothesis. In order to test this hypothesis, that is our assumption, we are going to select a sample from the population and then perform the testing. Here, the method that we use it to test it always depends on the nature of data and the reason for that analysis. So that's the core idea about this hypothesis testing. Now, while performing this hypothesis testing, so we have null and alternate hypothesis. So here the null hypothesis is the assumption that the event will not occur. Okay, it's something that the event will not occur. So a null hypothesis has no bearing on the study's outcome unless it is rejected. And we have something called as alternate hypothesis. Alternate hypothesis is a logically opposite statement of my null hypothesis. So if I accept the alternate hypothesis, it means I have rejected a null hypothesis. To give you an example, I have mentioned that smokers make more sale than men or non-smokers, okay, or vegetarians miss few flights. So let's do one thing. Let's take up a hypothesis, okay. Vegetarians miss few flights. Now, if I have a hypothesis, that is my assumption like this will be my null hypothesis. Okay, this will be my null hypothesis, which says that vegetarians miss few flights. So we are going to have an alternate hypothesis. In this alternate hypothesis, what we would say is it will be logically opposite to what we see. So logically opposite can be something as, okay, vegetarians miss more flights. So that can be a logically opposite statement. So null hypothesis is the current assumption, and the alternate hypothesis will be the logical opposite statement of the null hypothesis. And we will perform the hypothesis testing whether to validate whether the null hypothesis is correct, or whether the data that we have got follows the current belief, or whether it follows the alternate belief. So that's the overall idea in this scenario team. That's the importance of null hypothesis and the alternate hypothesis. Now that you have the basic understanding of this null hypothesis and the alternate hypothesis, so let's proceed ahead. Yeah, this is another example where I've got a hypothesis where hypothesis 1, which is my null hypothesis, says that accused is innocent. And the logically opposite statement is the alternate hypothesis, where accused is not innocent. Okay, so that is the overall idea about null hypothesis and the alternate hypothesis. We represent the null hypothesis with the help of the symbol H0, or the null hypothesis. So null hypothesis refers to the existing belief about a population. So we assume that the status quo is actually true. That's our assumption. And we have something called as H1. We represent this H1 with alternate hypothesis. Now, this is a logically opposite statement of my null hypothesis. In this scenario, so we are going to check the overall condition. So what we will do is we are going to consider the given statement and we'll perform the testing to validate whether it follows the null hypothesis or the alternate hypothesis. Okay, so now that you have understood about what exactly is this null hypothesis and the alternate hypothesis, let's take up a question to get a clear picture about the same. So here we've got a question that says that Edureka employees takes an average commute time of 35 minutes to reach the office and come back to their respective homes from office. Now, in this scenario, what exactly is the null hypothesis? So in this example, the null hypothesis is the one which is our current belief, which is nothing but Edureka team or the employees take an average commute time of 35 minutes to reach the Edureka office, and they take the 35 minutes to reach the home from the office. Okay, so that's my null hypothesis. And my alternate hypothesis is the logically opposite statement, which says that Edureka employees takes more than 35 minutes on an average to reach the office. So that is the first step. We define our null hypothesis and the alternate hypothesis. So if the null hypothesis holds good, then our current belief holds good. Maybe the current null hypothesis is accused is innocent. So that's my current null hypothesis. If the data follows else, it will follow the alternate hypothesis, which says that accused is not innocent. Okay, so in this way, we are going to specify the same. Next, here in this scenario, so if I go ahead with the alternate hypothesis, we are going to reject the null hypothesis. So here, when we are formulating this null hypothesis and the alternate hypothesis, suppose if your claim statement has the words like at least, at most, less than, or greater than, then in such scenarios, you cannot formulate the null hypothesis just from that claim statement. So what you have to do is you have to create something like this. Okay, so the rule to formulate the null and alternate hypothesis is like this. So if you like, it's like equal to, greater than or equal to, or less than or equal to. So these are the ways in which you are going to formulate your null hypothesis, and the alternate hypothesis is the opposite of it. Let's say if I'm using equal to, it is like not equal to. If it is less than or equal to, then it will be greater than. If it is greater than or equal to it, then it will be less than. So this is how we are going to formulate the null hypothesis and the alternate hypothesis. Okay, once we formulate this null hypothesis and the alternate hypothesis, then we will go ahead and perform the testing. Now, in this example, I have made use of greater than or equal to sign. Hence, okay, in my alternate hypothesis, I've got less than. So in my null hypothesis, in this scenario, okay, I think if you observe, I've got a greater than, and hence in the below one, I've got less than or equal to. So that's the overall way in which that we are going to formulate the null and the alternate hypothesis. Now that you have understood about null hypothesis and the alternate hypothesis, now let's understand about what does it mean by a critical value method. Let's take up a scenario. So we've got 𝐴_viral, and 𝐴_viral's claim is average accuracy in archery is 70. Now, over the 5 games of archery, this is how the data is. So the average score is 20. So if I've got the average score is 20, then it is less likely to believe this claim. And average score is 65, it is more likely to believe his claim because this is much closer to the value of 70. So we have got a claim that is 70. Now with the average score as 70, now if I'm saying that average score is 65, then it is more likely to believe because we've got the detail or we've got the information that the value is 70. So which is and the 65 that we have got, so it is closer. Okay, so the 65 that we have got is closer to 70, hence this is more likely to believe the claim. So in this way, so we'll get the value. So in this example, the mean is 70. Okay, and let's suppose if my value is 50, so like we have, in order to ensure that, okay, whether it holds good or whether it holds whether it does not hold good or not, we are going to look into the confidence values. Okay, on the left hand side you can see the lower confidence value, and on the right hand side you would observe the upper confidence value. So we will check whether it is present in that confidence value or the confidence region. Okay, now based on the values that we have got, so then we are going to where exactly the value would lie, whether it lies in the less than lower confidence region or greater than upper confidence region. So if we get in that specific scenario, okay, in such scenarios, so we are going to fail to reject the null hypothesis. So in this example, so we fail to reject the null hypothesis because it is present in my acceptance region. Okay, if I have any value which is in the acceptance region, then in such scenarios, we fail to reject the null hypothesis. So if I've got any value which is greater than like which appears in that red region, I would say that's a region where we would say that we are going to reject the null hypothesis and we follow the alternate hypothesis. Okay, that's the overall idea in this scenario. Now, in case if you are working on two-tail test, so the rejection region on both the sides of distribution. Now, if I'm performing the lower tail test, then in such scenarios, the rejection region on the left side of the distribution. And if I'm performing the upper tail test, then in that scenario, the rejection region is on the right side of the distribution. Now, let's take up an example. Here, we have got a AC store, okay, and this data over here describes the distribution of AC units per store during the summer. Now, this is the information that we have got, that is the distribution of AC units per store during the summer. Now, in this scenario, okay, so let's say we've got the sample of 36 stores. Then what we do is the first step is to formulate the hypothesis. So we'll define the null hypothesis and the alternate hypothesis. So the null hypothesis is 350, which means that there is no change in stored status quo. And the alternate hypothesis is the one which says that average is not equal to 350. Now, once we define the hypothesis, then we are going to select the sample. In this scenario, we'll look into the sample of 36 store. So in that scenario, the sample mean can vary very far from 350. Then in such scenarios, if I've got a sample mean which is very far from the assumed mean, then we are going to reject the null hypothesis and we are going to accept the alternate hypothesis. On the other hand, if I've got a sample mean closer to 350, then in such scenarios, we do not reject the alternate null hypothesis. We just proceed with the null hypothesis itself. So that is how we will make use of the critical value and then perform the analysis. So in this scenario, so we've got a mean and then I'm going to calculate the sample standard deviation, okay, which is given by sigma divided by square root of n, that is the number of rows that I've got. And from there, we are going to calculate the values. Okay, and here this describes about the sampling distribution of X. So once I have the value of sigma, so I'll check on the upper confidence value, and based on that, based on this, so where depending on where my data points would lie, I would decide whether to follow the null hypothesis or the alternate hypothesis. Okay, so that's the overall idea of this critical value method. Now, here, once we formulate the hypothesis, the steps that we would generally take in order to follow, the steps that we generally take using this critical value method is, first, we are going to calculate the value of Z from the given data set at a specific significance level. Okay, it will be alpha. So let's say it can be 5%. Okay, now once we specified the same, the next thing that we are going to do is, here we are going to calculate the critical values, that is upper confidence value and the lower confidence value from the value of Z. Now, once we calculate the critical values from the value of ZC, so we'll make a decision on the basis of the sample value mean X with respect to the critical values, that is upper confidence value and the lower confidence value. So with all these values, we are going to decide whether it follows the null hypothesis or whether it follows the alternate hypothesis. So this is called as a critical method. Next, we have something called as a p-value method. Now in this p-value method, so what we will do is we are going to check the value of p. Okay, we are going to check the value of p. Now in this scenario of p-value method, first we'll find the Z value for the sample mean. Now, once I find the value of Z, the next thing that we are going to do is we are going to get the respective p-value. Now, depending on value of p, so this p-value describes the probability of obtaining the result at least as extremes as observed. Okay, so here, it's the probability of obtaining the results at least as extreme as the observed results of a statistical hypothesis test. So assuming that my null hypothesis is true. So with this, we'll get the value of p, and on the basis of the value of p value, we are going to interpret whether it follows the null hypothesis and the alternate hypothesis. Now with the value of Z, we can get the value of p score, and with the value of p score, so we will check whether with the respective value of p, so p value, whether it is less than 0.05 or greater than 0.05. Based on this, we will either accept the null hypothesis or we are going to reject the null hypothesis. So that's the overall idea when it comes to the approach of the p-value method. So in case of p-value method, the steps that we follow in this hypothesis testing are, first we'll calculate the value of Z score for the sample mean point on the distribution using the p-value method. Then we'll calculate the p-value from the cumulative probability for the given Z score using the Z table. And this is followed by making a decision on the basis of p-value with respect to the given value of alpha. Okay, so these are the steps that we generally follow in order to make a decision using a p-value method. So you're now familiar with two methods. One method is called as the p-value method. The other method is the critical value method. Now that you're familiar about this, now let's go ahead and understand the types of errors that we have got whenever we are performing the hypothesis testing. So during the hypothesis testing, so we have got type 1 error and the type 2 error. So in order to determine whether it belongs to a type 1 error or the type 2 error, we find it with the help of the confusion matrix. So confusion matrix helps us to describe how my model is confused, in which scenarios my model is actually confused when it is performing the classification. So type 1 error means when the null hypothesis is true, but we are rejecting the null hypothesis and going with the alternate hypothesis. So that is a scenario where we call it as a type 1 error. And we've got the type 2 error, and this would occur when the null hypothesis is false, but we fail to reject it. So these are the two kinds of error that we generally come across while performing the hypothesis testing. Now, to get a better clarity on this, let's take up a case study. Now, in the scenario of case study, so let's say we've got the total number of successful search is given by CTR, which is nothing but the total number of searches. Now, as a data analyst at Flipkart and the product, now let's say you are a data analyst and the project manager comes to you and claims the following, that the search CTR has been increased from 35% to 40%. Now, this is what we are going to check. Like here, we are going to test whether the claim made by the product manager, whether it is statistically valid from the given data or whether it is statistically invalid. Now, in order to check that, you're going to perform the hypothesis testing. So the formulation of hypothesis testing is something like this. First, you are going to define the null hypothesis and the alternate hypothesis. The null hypothesis says that, okay, there's a 40% CTR, that is, say that P is equal to 0.4. And the alternate hypothesis is P is not equal to 0.4. So first step is defining the null and the alternate hypothesis. So you're going to collect the data. Let's say you have got the data of CTR, okay, from the given data set, and you've got the information about searches and the clicks. Okay, that is what you have got over here in this given data. Okay, now once you have got the population from the sample, you're going to collect from the population, you're going to collect a sample and you will focus on the sample mean. Here the sample mean, once you find it, so this is what we would get as an average CTR. So the average search CTR is given by 0.39 and the sample mean is 0.39 and we have got the sample size as 7400. Okay, so with this information, we are going to compute the test statistic. So I'll calculate the population variance. And once I compute my population variance, so I'll get the standard deviation. So with these values, we'll get the respective Z-score. Z-score is given by X minus mu divided by standard deviation of a sample. Okay. Now, once we have done this activity, so we'll get the respective test statistic. In this scenario, the Z-score. Now, once I have the Z-score, I'm going to check the scenario, okay, with the alpha as 0.05. So I'm going to check for a given data, okay. So what exactly will be its respective p-value? Now with the value of p, I'm going to decide whether it follows the null hypothesis or whether it follows the alternate hypothesis. Okay, so that's the way in which that we are going to interpret the results. So now that you have seen how we can perform the hypothesis testing, let's take up an example. So here the Z-test is given by critical, like in case of Z-test, we can do by two methods. One is critical value method and the other one is a p-value method. So while calculation of Z value, we'll be finding the standard error, which is given by population standard deviation divided by square root of sample size. And apart from that, we've got the t-test and the t-distribution. So coming to the t-distribution, so this is a diagram which describes the t-distribution. Okay, so t-distribution are a little bit shorter and flatter. So at the sample size beyond 30, so the t-distribution becomes approximately equal to the normal distribution. Okay, here we use this t-distribution when we are calculating the t-statistic with with degrees of freedom is n-1. Okay, this is how we decide whether to use the t-distribution or normal distribution. So if I've got a large sample, then I'll use the normal distribution. If I've got a very small samples and population variance is not known, then in such scenarios, we use the t distribution. And there is something called as a two sample mean test. Now in this two sample mean test, so here under this two sample mean test, we've got two sample pair test, okay, and two sample independent test. Let me show you what it would mean. So here, like two sample test, under this we've got paired and we've got unpaired or an independent. So this is another kind of testing that we have got, and we've got two sample proportion test and the A/B test. So these are the various hypothesis tests that are available in statistics, which we can apply it on a data set. All right, team. Now, in order to implement this in Python programming language, we can make use of various functions which are available inside the SciPy library. And from the SciPy library, there's a specific module called stats. Let me show you the official documentation of the same. So this is the official documentation page of SciPy.stats. Here, we've got various statistical functions under this SciPy.stats. So like various information, we can find an alpha continuous variable. See, you can, excuse me, if I want to find the chi value, we can actually get it using the chi function. So you can check out the various functions that are available in this scipy.stats. Okay, so you can also check as well and learn more about the various statistical functions that we have got with us under this scipy.stats. All right, team. So with this, we come to the end of today's session. So as part of our learning journey today, we have looked into what it means by hypothesis testing and how do we perform the hypothesis testing. So thanks again for joining in, and I'll see you next time. Take care, everyone.